next presentation is Smart Motorcycle Turn Safety Pro.
My name is in 2007, the National Highway Traffic Safety Administration stated that there were approximately 7 million motorcycles currently on the road today. These numbers have continued to increase at a rate of approximately 9% per year. Now, with so many motorcycles on the road today, safety is a major concern, especially since people involved in motorcycle crash are 6 times more likely to, be killed than people involved in a passenger vehicle crash. With this, motorcycle riders should always try to make their actions clear to people in other vehicles. This was a major inspiration for our project, for our senior center project, in which we set 3 goals. One was to add hazard lights, which are currently standard in most passenger vehicles, but are currently not a standard in most motorcycles. Another was to add auto canceling of the turn signals, which was that whenever a rider initiated a turn signal by pushing turn signal button, once they had completed the turn signal would automatically cancel without input from the rider. Another thing we would like to add was an in-helmet wireless notification system. Whenever you are wearing a helmet, your vertical vision is impaired, which means that the rider has to look down to look at their speedometer or to see if the turn signal is on, and this would cancel that and just put a notification system in the helmet, either through an LED or some kind of audible cue to alert the rider that there's a turn signal on. We did this using our Arduino prototyping board. This prototyping board is taking input from 2 momentary switches that act as either the left or right switches, just like they would in a motorcycle. If both of the buttons are pressed, this puts the microcontroller into the hazard mode, which allows both lights to blink in unison. Whenever they're pressed again, it takes it out of hazard mode and into off mode. Whenever either of the buttons are pressed, it allows the motorcycle to start blinking that light. It also starts taking data from the 2 sensors we're using. One is a gyroscope, which is used to calculate the motorcycle's lean angle. This angle is used to know if the motorcycle is currently performing a turn. Once we know this, we start taking data from the accelerometer, which gives us the current velocity of the motorcycle. Once it reaches a constant velocity, we go ahead and turn off the turn signal. This semester, we have actually completed the design of it, and we have also we programmed the microcontroller to perform as a turn signal controller, and have actually also started in calibrating our sensors and taking in data from them. Our goals for senior design 2 are to start implementing a filter that will actually filter out the noise caused by the trembling platform of the motorcycle, and also from non-ideal road conditions. And we will also implement the in-helmet wireless notification system using the XB platform. We invite all of you guys to visit our poster after the presentations, and we'd like to open it up for any questions. Yes.
2 questions. One is, as far as I understand, with cars, the similar mechanism is simply based on the position of the steering wheel.
Yes.
Why did you go through all the trouble of using gyroscope and accelerometers?
At first, we thought of using just a Hall sensor, just to note the position of the handlebars. The thing is that with a motorcycle, you actually use something called counter steer, which means that you turn the handlebars in the opposite direction and actually lean in the direction that you're trying to make your turn in when you're completing a turn. And usually that angle is 10 degrees to normal in either direction. So we're using the gyroscope to try to detect, things outside of that threshold. And then we'd like to keep the turn signal on until we know that, we are going at a constant velocity. And this was done, just in case you put your turn signal on and then you have to change lanes and then you have to, go again, where actually you want to measure that angle to be, a certain threshold. So there's actually no easy way to just do this mechanically, or, just through the position of the handlebar, so we had to actually calculate the angle and, also accelerometer information.
And second question, you mentioned about communication of some kind of either visual or audible notification inside the helmet of the driver.
Yes, the thing is, like any system,
Do you have it already planned, or is it still in the...
It's still, yeah, This semester, we're mostly trying to accomplish the actual, auto transfer first. The reason that we want to implement the in-helmet wireless is because, like any system, we don't think this is we want this to work 100% of the time, but we don't, there's cases where that's not going to happen. So if, by having that in-helmet system, it allows, in case this system fails, there's a backup to alert the rider that, the turn signal is still on.
And my question about that was, have you thought about possible interference, which is two motorcycles one next to the other?
We have, at first we were just going to use a very low powered solution. The reason that we want to use XPs is because they're addressable, so we can, address each of them individually.
Other questions? How many of you ride motorcycles?
Just me.
Did you have a specific motivation for choosing this?
Yes, the main motivation is just that, like any rider out there, because of when I'm wearing my helmet, I can't see, I have to actually visually put my head down. So what happens is you turn on your turn signal, you complete a turn, other stuff happens, which you have to look out for, and then you forget about your turn signal, and then 5 minutes later you look down and it's been on the whole time. So, and you see this happen with other motorcycle riders. Usually, I'm sure the oters people that don't ride motorcycles are thinking, like, man, this guy must not be paying attention. But yeah, that was the main reason, because it's something that we take for granted when we drive a car. But when you ride a motorcycle, you really notice it.
So now I think coming back to what Dr. Raja asked before, who is doing what?
Okay. Our new folk, he took care of with me. We programmed a microcontroller to act as a turn signal controller, and he also did market research, which means that he looked into the actual cost of turn signal controllers now, aftermarket controllers, and also actually we had a questionnaire which we took out to see actually how many people had, if anybody had the system right now, which nobody had it. Josh was in charge of calculating selecting the gyroscope and also calibrating it and actually getting data in from it. Asifer was in charge of the accelerometer, same thing, calibrating data. Peter was in charge of assisting them as well as researching into an algorithm to use to actually filter out the data. Because by itself, we're getting, as soon as you start moving, because we're using an inertial measurement unit, as soon as you start moving this, we start getting drift, and both the gyroscope can start getting noise in the accelerometer. So we are actually planning to next semester use a common filter to actually, filter out this noise and start getting, accurate data in.
Why use a common filter?
We actually started researching and we saw what other people had done. Just in most of the stuff out there is self-stabilizing, robots kind of, and all of them everybody's using the common filter. We also looked into using the complementary filter, and there's a lot of variables in there. The common filter is a very complicated filter, but from all our research, it's the one that gives us the most accurate data out.
Can I make another comment?
Oh.
You should also look at any studies that have looked at the safety of adding extra things like this. And Virginia Tech Transportation Institute just finished a project last fall, specifically on motorcycles. Looked at about 200-300 motorcycle drivers over a year, and funded by NTSB. So I get in contact with that fellow that was saying that. They didn't look specifically at that, but what Dr. Taco and look at something like it's either visual or audio when you're kind of getting a warning. You don't want to do it visually because that's already full attack. So auditory type sensor is probably better than visual because it's already compromised. Any other questions?